Hello, Chem 130 students. Welcome back to our fourth video for Chapter 3 on conversions and the metric system. All right, a note before we move on. On your homeworks, exams, and quizzes, we expect you to use the conversion factors we have discussed. Again, there were 5 metric conversions, 9 English conversions, and 3 crossover metric to English conversions that will be given to you. You can only use those conversion factors. You should not ever Google your own direct conversion factors because that makes all the problems one step. You're not going to learn how to do 3, 4-step conversions if you keep practicing 1-step conversions at home. So practice at home correctly. Now, for written work, we're going to make sure you show every step, and that's the only way you'll get credit. If it's an online course you're taking, we're going to ask you what the steps are, not just the answer. So again, you've got to use the correct conversion factors, whether you're in face-to-face, hybrid, or an online course. Okay, so only use the conversion factors from your textbook, the ones we've discussed in these slides, or it's a 0 for that problem. All right, thanks. Next up, volume by displacement. This is just a reminder. I want you to remember that a cc stands for cubic centimeter, cm third, and that a cubic centimeter is a milliliter. Those are all the same thing. So again, if I have 7.2 cc's, how many milliliters is that? Yeah, 7.2, because they're the same. All right, so here's volume by displacement. Let's pretend I have a really big diamond and I put it in a graduated cylinder that contains 20 milliliters of water. So I put the diamond in, the volume rises to 34.7 milliliters. What's the volume of the diamond? Did you say 14.7? I hope so. Milliliters, right? Yeah, that's right. How did you get that? Oh, you subtracted. We started with 20 milliliters. Then the diamond went in and pushed the water up to 34.7. So the difference between them is due to the diamond. So you subtract. Good job. For fun, what element is a diamond made out of? I don't have mine on right now, but a diamond is made out of carbon. Yeah. So what state of matter is carbon? Remember, state of matter means solid, liquid, or gas. What's a diamond? It's a solid, right? No one has a gas ring. Oops, gone. So yeah, carbon is a solid. Sometimes people say it's a gas, and I don't know why. All right, so anyway, we subtract to get our volume. It's called volume by displacement. You just subtract to get that 14.7 milliliters. And a diamond is made up of carbon. Carbon is a solid. Volume by calculation. How do we calculate the volume of a box? A box. Something rectangular with 90-degree right angles. Okay. Length times width times height. Like this, we have length times width times height. I could figure out the volume of this book because it's right angles. Length times width times height. Cool. So now calculate the volume of a shoebox measuring 24 centimeters by 11 centimeters by 16 centimeters. And you say 4,224. Wrong. What's wrong with 4,224 as an answer? Couple of things. No, there's no unit. What is the unit? What is centimeters times centimeters times centimeters? Centimeters cubed, or cc, or milliliter, same thing. Okay, so 4,224 cubic centimeters. Still wrong. Why is it wrong? Look at what we're given. 24, 11, 16. How many sig figs are in those? 2. So the answer needs 2 sig figs. So you got to round it to 4,200 with placeholder zeros. Yeah. So you can only have 2 sig figs. 4,200 centimeters cubed, or milliliters would be fine, or cc's would be fine. Caught you on that one. I know I did. I know I caught you on the sig figs for that one. Yeah, tricky, tricky. All right, so remember your sig figs when we're multiplying and dividing. Sig figs. All right, next up, new topic, density. Density is the amount of mass per volume. Per means divided by. So density is mass over volume. If you draw a heart and put a line through it, you get an M over a V. Let me say that again. If you draw a heart and put a line through it, you get your mass over your volume. So I heart density, mass over volume. What are the units? Well, mass is grams, and volume can be milliliters, cubic centimeters, or cc. It's all the same. So all 3 of those units are fine. You can think of density as how much stuff or how many atoms are packed inside an object. How many atoms are in a given amount of space or volume. So density of the states of matter. So state of matter again means solid, liquid, or gas. Which state of matter is the most dense? Which state of matter has the atoms packed the tightest together, closest together? I hope you said solid. Yeah, solid. Solids are generally speaking the most dense. What would be the least dense, solid, liquid, or gas? Yeah, gas, because the atoms are far apart with lots of empty space in between them. So a gas. Yeah, look at these example densities. Air, 0.00129 grams per cubic centimeter. That's little number, not dense. Water, 1 gram per centimeter cubed. Yeah, it's around 1. Liquids are around 1. The density of gold, a metal, 18.9 grams per cubic centimeter. Yeah, that's bigger than the water, and water and gold are both way bigger than the gas, air. Good job. So we got some calculations with mass over volume for density. Type 1 is just to calculate density itself. This is easy. All you have to do is divide mass over volume. And remember our heart with the line through it. Remember it's mass over the volume. All you have to do is divide. Type 2 is a little more complicated. This is when you're calculating the mass or the volume given the density. We're going to do these types of problems by using the density, which is given as a conversion factor. For example, the density of chloroform is 1.48 grams per milliliter. We can write that as a conversion factor, which remember is a fraction. So we can write it 1.48 grams over a milliliter, or 1 milliliter over 1.48 grams. So density can be a conversion factor, which means we don't start with it. Never ever start with a conversion factor. Start with the given. So when we have a density problem where the density is given, you don't start with it. Start with the other given number. We'll look at examples in a minute. Let's try a type 1. Let's calculate density. What is the density of my necklace? If 484.56 grams has a volume of 25.64 milliliters. So I have 2 numbers. I have grams and I have volume. Density is what? Mass over volume. So we're going to take the mass. Which number is the mass? The grams. 484.56 grams. Divide by the volume, which is the milliliters. So divided by 25.64 milliliters. Whew, big long number. How many sig figs? We're dividing, so it's sig figs. Well, let's see. The grams has 5 sig figs. The milliliters has 4 sig figs. Go with the least, which is 4. So we're going to get, wow, 89 is going to round up to 90, so 18.90. So density is mass over volume. Density is going to equal the 484.56 grams over the 25.64 milliliters. and that equals 18.90 grams per milliliter. Look at that unit. Grams and milliliters don't cancel, so it's still there, grams over milliliters. Cool. That's a type 1 density problem. We're calculating the density. All we do is divide mass over volume. Pay attention to sig figs. Pay attention to units. All right, let's try these practice problems now. These are type 2 density problems. How many grams would 17.5 milliliters of chloroform mass if the density of chloroform is 1.48 grams per milliliters? Am I calculating density? No, it's given. 1.48 grams per milliliter, it's given. So density is given. What did we say earlier about density? Because it can be written 1.48 grams over milliliters, it's a fraction, it's a conversion factor, and we don't start with it. So if we're not starting with the density, what are we starting with? Yeah, the 17.5 milliliters. Let's start with that. 17.5 milliliters. Excellent. Density comes next. It's the conversion factor. What needs to be on the bottom? Grams or milliliters? We want the unit to cancel out top to bottom. So we need the milliliters on the bottom. Yeah, so it's going to be 1.48 grams over 1 milliliter. Milliliters will cancel. We got grams. Are we done? Yeah, the question asked how many grams. We got grams, so we're done. All right, 17.5 times 1.48 divided by 1 equals, wow, this came out with 3 sig figs. How many sig figs should we have? Well, density is a measurement, so it counts. So we got 17.5 is 3 sig figs, and the 1.48 counts, it's 3 sig figs. So 3 sig figs, and the answer actually came out on the calculator with 3 sig figs. So 25.9 grams. Milliliters canceled. It's not grams per milliliter, it's just grams. Milliliters cancel, it's grams because we asked how many grams. We got our grams. All right, if you want to, try this second one on your own. Hit pause. Try this second one on your own real quick. All right, I hope you tried it on your own. You learn better when you try it on your own. Anyone can listen to me and follow along. Following along is not learning. Trying on your own is learning. So I hope you gave it a try. If not, hit pause now. All right. How many milliliters would 0.0735 grams of chloroform occupy if the density of chloroform is 1.48 grams per milliliter? Are we calculating density? No, density was given 1.48 grams per milliliter again. So density is given, don't start with it, it's the conversion factor. Start with the other number. What's the other number? Yeah, start with the 0.0735 grams. Good job. Density is next, in the parentheses with the line through it. Now, we're starting with grams, so what's on the bottom? Grams. The 1.48 grams is on the bottom. The 1 milliliter is on top like that. Grams cancel. We're left with milliliters. Does that answer the question? How many milliliters? Yes, it does. We're good. Okay, so 0.0735 times 1 divided by 1.48 equals, ooh, big long number, sig figs. We started with 0.0735. Zeros in front don't count. 3 sig figs. And then the density is a measurement, 1.48, 3 sig figs. So we need 3 sig figs. Now the answer is 0.0. Do those count as sig figs? No. So we need 3 sig figs after that. So 497. 0.0497 milliliters. Good job. All right, we'll take a break there and come back and finish up this chapter Chapter 3. Hope you're doing okay. If you need to watch this one again, you're going to see density a lot, so it's important. Good luck, Chem 130 students. See you on the flip side.